So let's go ahead and do example 1. And I'm looking at it as angle, angle, side. And that would be 2 angles and a side. That would be a good candidate for law of cosines. So if you take a look at it, what are we going to look for first? You got to pick a side, most likely, or pick an angle. Probably the angle's easy. Can someone find angle B real easy? How? Yeah, you take the 180 degrees and you subtract the sum of the other 2 angles, which is 31 and, is that a 36? 67. It adds up to 67. So 180 degrees minus 67 degrees is how much? 113? Yes. So that's a 113 degree angle. So somebody told me in another class, it's always a good idea to find missing angles first if you can. If you already have 2, you may as well, because it makes your life easier. So now what I can do is I can choose to find either side C or I could find side B. Doesn't really matter. Once you find side C or B, then you're pretty much done because you have everything else. So I'm going to find side B. So I'm going to go, since I'm looking for side B, I'm going to put the side B on top and put sine of angle B. And then for the other one, I'm going to put, okay, here's angle A. It matches with this 14. I'm going to put 14 over sine of A. I could have plugged in the angle. I don't know why I didn't, why I put the 14. I could have just put the A instead and said, oh, that's my generic. But since I don't know B, B goes over the sine of 100 and, you said it was 113, Diana? Yes. 113. A, I do know it's a 14 divided by the sine of the angle 31. The reason I put the small b on top, it makes it easy to solve for it. Because all I have to do is multiply both sides by sine of 113 degrees and it cancels here. And then I got to multiply it over here, sine of 113 degrees. So here's what the answer looks like, or the final equation. Side B is equal to 14 times the sine of 113 degrees divided by the sine of, what is that, 31 degrees? Yes? Nobody's saying anything? Yes. Okay. Could somebody plug that in and give me my approximate answer? While you do that, I'm going to put 113 over here for this angle, 113 degrees. Anybody? 25.02, that'd be 25.0 degree, not degrees. It was a side. What's the unit? Feet. So I'm going to put, that would be AC, right? AC. So AC, I'm just going to write 25 degrees. Now I got to find side C, which is AB. So I'm going to do the same thing again. C is what I don't know over sine of, its angle was 34 degrees. Equals to, you can pick whatever you want now. You can pick either pair. You want to pick the same pair we did in the other problem? I think you could pick the 14 divided by sine of 31 degrees. Somebody asked me, what if I pick the other one? Will I get the same answer? Yes. So C will be equal to 14 times sine of, I could read my own writing, 14 over the sine of 34 degrees divided by the sine of 31 degrees. And what do we get? Is it a 6? I did that this morning too. 36. Thank you. It is 36. I remember they yelled at me too. What'd you get? Don't be shy. Nobody?
15.87.
15.87. 97. 15.97, but if I round it, what did they tell me to use? They didn't tell me to use any decimals, did they? It's possible. If they didn't tell me, it's possible they wrote 16. It's possible. I don't like it. At least you should have some precision. But that's the answer I would take. The second problem is a side angle side. That would be definitely a good candidate for one of the law of cosines. So let's take a look at it. I like it because I have the included angle. So I'm probably going to be looking for side R. Probably side R. And let me show you how we set that up. If you're looking for a side opposite of the angle you have with law of cosines, we do this. R squared must be equal to each of these two sides being squared. 17 squared plus 28 squared minus 2 times 17 times 28. One more thing. It wouldn't be the law of cosines without the cosine. Cosine of what angle is that? Angle R. 87 degrees. Is that right? Now, that's a lot of work. R squared equals to, could somebody please tell me what 17 squared plus 28 squared is? $17 squared plus 28 squared, anybody? 1,000 and what? 1,073? Minus, while you're at it, could you tell me what 2 times 17 times 28 is? How much? 952. And then I'm going to bring down the cosine of 87 just for now, okay? This is how I would do it on my paper. So I can keep track and not lose anything. So now, well, I guess I don't have to do anything. Just key that in your calculator straight across. R squared is? It's a what? I just want to know what all of this right-hand side is. 1073 minus 952 cosine of 87 degrees. Key that whole thing in. 1,023? 1,023 what? How many decimals? Give me 3 decimals.
There's only 2.
Oh, 18?
Yes.
Now I do what to both sides? Square root both sides. Only take the positive answer. It's probably 10 something. Anybody?
31 point.
Oh, it's bigger than I thought.
99.
It is 31.99. I'll bet you any money the author got lazy and used 32. I bet you she did. I don't know for a fact, but that would be in the unit would have been in kilometers. That was just finding R, or labeled QP. That's this one right here, QP. So 31.99 kilometers. Why are they wanting 2 angles here? I have 1 angle. How would I find one of the other angles? Probably law of sines. Okay. Now that you know this was around 32, you could easily do a law of sines very simply. I'll just set one up. I'll use the 32 and be lazy. 32 would go with these two go together. So I can find angle Q by going across the street from 17. So sine of Q over 17 would equal to the sine of 87 degrees over the approximate 32. Normally, I would not put in 32. I would stick to my guns and do 31.99, or no, yeah, 31.99. But that way, all I got to do is multiply both sides by 17, and sine of Q would be 13 times sine of 80, what was it? 87 degrees divided by 32. That gives me a decimal. Sine of theta is something. But how can I get the theta, or A, it's Q, I'm sorry, it's a Q. How do I get Q out of sine of Q? Inverse sine. So I would do the inverse sine of this side. I would do the inverse sine of this answer, and we get Q to be what angle? You got to do the inverse sine of that whole fraction. It's a lot of work. I would just type it in inverse sine, second sine, or inverse sine of that whole fraction. 13 sine of 82 divided by 32. I would just keep that in the parentheses and do the inverse sine of that. Why do extra work? Anybody? I don't have, you got all these calculators out, but I don't have enough of you even pressing the buttons. The bottom? The top? Top had a 13, the bottom has a 32. And there was a sine of 82. What's that? I don't know.
Isn't it 17?
I don't know. Yeah. Nobody said nothing. When I wrote 13 down, I do see a 17 here. But nobody said anything, so it is a 17. 87. See, I'm blind, guys. You gotta catch me right away. That's why you were quiet. Don't make the blind man mad. All right, give me the answer then. The measure of angle Q is what? 32 degrees? Exactly?
0.04.
Okay, 32 degrees it is. So that's 32. How fast can I get angle D? Really fast, can't you? Because you got a 32 and you already have an 87, 87. So 180 minus that is how much? 61. All right. That was just a couple review problems, and I will post this for you. Let's go over here and look at, I don't want to do no more on this lesson. Go to the next page on the area of triangles. Now, whatever I don't get done, I've already posted some of this online already. You can find it. Look at this triangle. Triangle ABC. In the old days, to find the area of this triangle, you had to use area is 1/2 times base times height. Isn't that the geometry formula? The base is always the bottom. The height is always, sometimes it's an imaginary number, imaginary line that is perpendicular to the bottom. Sometimes that was the hardest thing to do, to find out how high this triangle was. Very difficult. So in the past, we knew A was 1/2 base times height. Today, we can involve Mr. Trig to find out something about this angle C. I actually could have picked any angle I wanted to, but this is the easiest because I can talk about this height of the triangle and create a second triangle as the left-hand side, or the right-hand side. So as I look at sine of C is what letter over what letter is what I'm asking you. Looking at this smaller triangle. I'm hoping you're thinking opposite over hypotenuse, right? I hope. So what would be the opposite of angle C? Say it again. What leg of a right triangle is opposite C? A. That's not opposite. That's the hypotenuse. It's the H. What's the hypotenuse? A. I know what happened. You're not used to seeing, the H is weird for you right now because you want to call it hypotenuse, hypotenuse. No, it was a leg of this right triangle. So let me write that out. Sine of C is H over the A of that triangle. Now, if I solve this for H, it would mean multiply both sides by an A, and the A's cancel. That gives me H equals to A sine of angle C. Now, if I take this relationship for H, which is the same as this H right here, and I take H and I substitute that in, look what it looks like. If I plug that in for H right here, A now is equal to 1/2 base times the A sine of C. Well, I don't like that the B before the A, so I'm going to write it as formula for area is A equals to 1/2 AB sine of C. That's your formula. Now, how are those related, the A and the B and the sine of C? Let me go back to this picture here. Erase everything. And let me show it you. This is the formula. It says A equals to 1/2 AB. Look at the A. Here it is. Look at the B. Here it is. Sine of C. Here it is. What do you notice? How are they related? I hope you see that it's special. It's that grilled cheese sandwich that I said in my video, right? You got a slice of bread and a slice of bread and the cheese is in the middle. That's called, that angle C is called an included angle. Any triangle in the world, if you have the two sides that include an angle and you have the angle, you can find the area of this triangle. Let's do an example. Here's already set up for you. Look at this triangle. It's not a right triangle, so it'd be very hard to find the area of. You could do it. It would take you a while, though. Matter of fact, half of you probably couldn't do it. You couldn't remember your geometry methods anyway. Who in the world is going to remember how to find the altitude straight up, straight up, straight up till it's perpendicular to that line? Good luck to find out how high that triangle would be. But good news, I don't care. I can call this A, I can call this B, I can call this angle C. It's included into A and B. So area will be 1/2 times 11 times the 16 times the sine of the angle that I know, a 105-degree angle. Piece of cake. Just key it in and give me your approximate area. I can't wait to hear the answers. Some of you guys are just sitting there doing nothing. You cannot complain to me if you can't pass your test the next time we meet. You got to practice.
85.00.
Okay, he said round to the nearest tenth. 85?
Yeah.
So I'm going to say approximately 85 degrees. No, it's not degrees. What is it? Is it your feet?
Oh, I don't know actually. Can you just put it in the calculator right now?
Is it feet?
Squared.
Ah, feet squared. Thank you. Thank you, Desiree. Number 2 is also ready to go. No thinking aloud. Just type, put it in your formula. Area equals to 1/2 times 25 times 21 times sine of 24 degrees. Piece of cake. You could do this with your eyes. No, you can't. Close your eyes.
106.7?
How much?
106.7?
Can I have the unit? That would be 107 then, okay?
Oh, okay, 107 inches squared.
Square inches, absolutely.
Oh, square inches.
Or inches square, same thing. I'm just tricking you. What's wrong with number 3? What do I not have? Yeah, but I'm missing another side of where?
It's 2 angles.
I have 2 angles. I don't have 2 sides. So I either need to find out what that side is, or I need to find out what that side is. I don't know. I think they both are going to cause me to have to do double work. I need to find one of those sides, and look what I have. I have angle, angle, side. No, I have side, angle, angle. Isn't that what we use the law of sines for? So how can I do a law of sines right now? If I'm looking for, let's say I'm looking for x. X would go over the sine of what? Uh-oh.
9. I mean, 70.
I don't have it.
Oh. Oh, okay, never mind.
But could I get it? I have 2 of them. So what is that angle going to be then? How much? 45?
45.
So 45 degrees. Oh, you want to leave now? Oh, I guess you can. Yeah. You want to find the rest of this video online? Okay, it's learning. And work on your review, okay? Equals to, I guess I'm going to pick side of what? The 7?
Yes.
Yeah, I don't have the other one, do I? I don't have this one, do I? No. 7 over sine of what? 76 degrees. X equals to 7 sine of 45 degrees over sine of 76 degrees. Could someone key that in? I got bad news. We're not done yet. Seven sine of 45 divided by sine of 76.
54.65.
I'm going to use a lot of decimals. 54, 65, 65. That's the side, guys. You said 54.6565.
Sir,
You don't agree?
we got something else.
What'd you guys get?
5.101.
I don't think the side is I don't know. Anybody else got 5.101? Oh, I got a couple heads. All right. That looks like a 5 to me. I don't know what happened then. I got a lot of people. Did anybody get, oh, you did it wrong? So 5.01. No, let me keep 5.01. 5.01.
It's 5.10.
Oh, okay, 5.10. Did you say 01?
101.
Oh, 101. Oh, good. I like that even better. So now let's use the area formula for a triangle, because that's what we're doing. Area equals to 1/2. And so what angle am I going to be using then? Obviously, I got this side and I got this side. What angle will I be using? The which one? 59? So 1/2 times 5.01 times the 7 times the sine of 59 degrees. So we had to do 2 steps. We had to do double the work. We had to find a missing side. Now we're using the area formula for trig. What does that give me approximately?
Wait, it's the sine of 59, right?
59, yes.
I got 15.3 or 15.
So 15.3 or approximately 15. It depends what they say to round to. Nearest tenth. You're going to want to keep the 0.3. But by the way, 15.3 what?
0.
I need units.
Sorry. Millimeters squared?
Millimeters squared, yes. All right. Now, in the video, I don't think I finished this one, so that one's yours. I think I did a couple of these here, and I dropped down here to Heron's formula. I'm just going to write out the formula for you, and then we'll call it quits for today. If you got a triangle with sides A, B, and C, I don't know where this Greek mathematician figured this out, but he figured out that if you take all three sides and add them together, A plus B plus C, and you add them together and take 1/2 of it, we call that S. Now, why do I need S? Because Heron's formula says area is equal to the square root of S times S minus one of the sides A times S minus the other side B times S minus the other side C. And again, S is equal to 1/2 of A plus B plus C. Where in the world did somebody figure this out? I have no. We're talking about people hundreds of years ago. I don't know when Heron was born. It may have even been over 1,000 years ago. It may have been 3 years ago. Who wants extra credit? Find it on Google it. When was Heron's formula created or discovered?
Sure, the answer is lots of trials and error. Trial and error.
You think so?
Yeah.
I don't know. I wouldn't even begin to guess at trying those. What year?
60 CE.
6?
60 CE.
60 BC? CE. Okay, so that's after, what does CE mean? Common era, that's like after Christ, right?
About 30 years after Jesus died. Yeah.
About 30 years, wow. How did that guy he must never went on any dates.